Welcome back to the video series on integration and differential equations. Today we're going to do a couple more examples involving the basic trig forms. So here's our first example. There are three identities that often come up when we're doing these trig integrals. The most familiar one is probably the top one, sine squared theta plus cos squared theta equals 1. But the one we're going to be using in this problem is the bottom one. So tan squared theta plus 1 equals secant squared theta, where theta can represent any angle. So we'll replace this entire expression with a secant squared term. So let's rewrite our integral. It's now the integral of x times secant squared of x squared dx. Next step is to do a substitution to get this looking like a basic trig integral. So let's sub u equal the angle. In this case, the angle is x squared. So du is equal to 2x dx. And if we look up at our integral, our original integral in the problem here, looking back over here, we've got x dx in our integral, and that's what we want to rewrite. So to move from this line to this line, we're dividing by 2. du over 2 is another way of rewriting x dx. So now we can rewrite our integral from our last step. The x dx is taken care of by the du over 2. So let's write the 1/2 out in front, the du at the back. And then we've got this secant squared expression. That's going to be rewritten as secant squared u. Perfect, so that is one of our basic trig integrals from our previous video. And you may remember that the integral of secant squared u with respect to u is going to give you tan u plus a constant. And very last thing we need to do here is just go back to our original variable. So instead of writing u, we'll write x squared. And why don't we write this a little more concisely as tan of x squared all over 2 plus a constant. And that's our final answer there. So here's our second example, 1 minus cos of e to the x over sine of e to the x times e to the x dx. Well, right now this doesn't look like any of our basic trig integrals. First thing I would suggest doing is just focusing on this fraction here. We've got a single term in the denominator, so we can rewrite this fraction as two separate fractions. We could say it's 1 over sine of e to the x minus cos of e to the x over sine of e to the x. Put all this stuff in brackets, and that's still being multiplied by e to the x dx. Okay, so we're on the right track. In order to move forward, we need to remember a few more identities. So let's remember that all the trig functions can be written in terms of sine and cosine. Tan theta is sine theta over cos theta. Cotangent theta is the reciprocal of tan theta. When you take the reciprocal of a fraction, you're flipping that fraction. So you could say cotangent theta is cos theta over sine theta. Then we get secant theta, which is the reciprocal of cosine. So 1 over cos theta is the same thing as secant theta. And cosecant theta, that is the same thing as 1 over sine theta. So let's see if these identities can help us rewrite our integral. So first thing we run into is 1 over sine of an angle. So let's call that cosecant of e to the x. And then we're subtracting off cotangent of e to the x. So all that stuff is in brackets, and that gets multiplied by e to the x dx. Great, so now we're definitely on the right track, and it's time now to make a substitution. So typically for these trig integrals, we're substituting u equal the angle. In this case, that would be the e to the x that is sitting inside these trig functions. Okay, so if u is equal to e to the x, then du is e to the x dx. And with that, we should be able to rewrite our integral in a much friendlier way. So continuing from our previous step, I'm going to say we've got the integral of cosecant u minus cotangent u, and that's all being multiplied by du. Perfect, so we're ready to apply those formulas that we saw in the previous video. So let's start with the integral of cosecant u. That's going to give us negative ln absolute value of cosecant u plus cotangent u. So that's the first term done. And then we're moving over to the integral of negative cotangent u. Well, if you remember, the integral of cotangent u is going to be negative. So we've actually got a double negative going on here. It's going to be plus ln of, and integrating cotangent u, we're getting cosecant u inside the absolute value there. Again, we've dropped the negative sign because we've got minus times an integral that's already going to be negative. So plus ln absolute value cosecant u, and then we just need a plus c at the end. So in order to turn this into our final answer, the very last thing we need to do is go back to our original variable. Let's replace those u's with e to the x's. So we've got negative ln absolute value cosecant e to the x plus cotangent e to the x, and then we're adding on ln of cosecant e to the x, and then closing our absolute value sign, and then finally plus c. So there we go, we've got our final answer, and we've had some practice calculating two fairly tricky trig integrals. We've done lots of practice with our identities along the way. So thanks for watching, and we'll see you in the next video.